Google's biggest AI constraint is not the GPU. It is the memory chip feeding it. At the exact same time, agents are quietly graduating from click the website to control the greenhouse. One is a supply chain story. The other is a product story. They collide in a really awkward place. Hey friend, it's Monday, January 5th, 2026. I'm Ting Yan. The theme today is the efficiency inflection. Bigger models are running into physical limits. So the next edge comes from doing more with less. Better chips, better memory, better inference tricks, better agents. Lead story first. Wall Street is finally pricing the unsexy part of AI. Memory. Morgan Stanley is calling for DRAM and NAND price hikes. The driver is demand for high bandwidth memory, the kind packed next to advanced GPUs. That means training frontier models gets more expensive. Not because you cannot buy GPUs, because the data cannot get to them fast enough at a sunk cost. If you're shipping a product, this is not trivia. Your inference bill is going to have a memory tax baked into it. The teams that win this year will not be the ones with the fanciest model. They will be the ones with the lowest cost per useful action. That cost pressure is exactly why the silicon story is turning. Goldman is projecting AI ASIC chips, meaning custom accelerators, matching GPU volume by 2027. This is not only inference anymore. The claim is custom silicon is moving into training too. Translation: hyperscalers want control. They want energy efficiency. They want predictable supply. And they want to stop paying the general purpose tax. Using my framework here, the signal is that compute is getting unbundled. Chips, memory, networking, they are becoming separate battlegrounds. The noise is the endless benchmarks chest thumping. The second order effect is that model architecture gets dragged toward what the hardware can feed. Efficiency becomes the product requirement, not a nice to have. And the most important word here is memory. Today's quote of the day is, high bandwidth memory, HBM, is a critical bottleneck for AI beyond just GPUs. That's Jensen Huang on X. I love that we built an industry on move fast, then got slowed down by basically very expensive rectangles of silicon. On the ground, you can see the efficiency inflection showing up in three places. First is distributed compute is getting treated like national infrastructure. China just activated a long-distance computing network that links multiple data centers into one machine. That is sovereignty, expressed as latency budgets. If you build on top of that kind of fabric, you stop thinking in one cluster. You start thinking in one country-sized computer. Second, agents are stepping into closed-loop control. Someone wired Claude up to a smart tomato grow tent. Sensors in. Arduino commands out. That sounds cute, but it is the same template you use for labs, warehouses, and bioreactors. Once the agent can act, reliability becomes the whole job. Third, the agent surface area is expanding fast. A new method lets agents use real browsers with dynamic pages and messy text. That means more automation in workflows you already run. Procurement, support ops, your bosses, internal IT. The constraint shifts from can the model read the page to can you trust it with the clicks? Have a tip? Send it my way. And the big question I'm carrying into tonight is this. As memory becomes the choke point, do you optimize your product around cheaper tokens or around fewer actions? I'm Ting Yan from Chain of Thought, and I'll see you tomorrow.